Have you ever stared into a campfire and wondered, what exactly is happening in there? We see fire all the time. We use it to cook, to stay warm, and we're fascinated by its flickering dance. But how does it actually work? What is fire, really? Well, today we're going to dive deep into the science of combustion and unravel the secrets behind this incredible natural phenomenon. First things first, fire isn't a thing, like a rock or a glass of water. It's not a solid, a liquid, or a gas. Fire is a process, a chemical reaction. And for this reaction to happen, you need three key ingredients. You might have heard of this before. It's called the fire triangle. The three sides of this triangle are fuel, heat, and an oxidizer, which is usually oxygen from the air around us. Take away any one of these three things, and the fire goes out. It's that simple, yet that complex. Let's break down each side of the triangle, starting with fuel. Fuel is anything that can burn. This could be a log of wood, a piece of paper, gasoline, or even a candle wick, essentially. Fuel is any material that contains stored chemical energy. In wood, for example, that energy was originally captured from the sun by the tree through photosynthesis. So when you burn wood, you're releasing energy that came from the sun millions of years ago. Pretty cool, right? But just having fuel isn't enough. A log of wood can sit in your backyard for years and never spontaneously burst into flames. That's because it needs the second element of the fire triangle, heat. Heat is the trigger, the activation energy needed to start the chemical reaction. You can provide this heat with a match, a lighter, a spark from flint and steel, or even focused sunlight from a magnifying glass. So what happens when you apply heat to the fuel? Let's stick with our log of wood. When you heat the wood to a high enough temperature, somewhere around 300 degrees Celsius or 570 degrees Fahrenheit, a process called pyrolysis begins. This is a crucial step. Pyrolysis is the thermal decomposition of the material. In simpler terms, the heat is so intense that it breaks down the complex compounds within the wood, like cellulose, into smaller, flammable gas molecules. You're essentially cooking the wood and releasing a cloud of burnable gas. This gas is what we often see as smoke rising from wood just before it ignites. Now we have fuel in the form of flammable gas, and we have heat. The final piece of the puzzle is the oxidizer. For most fires on Earth, that's the oxygen in our atmosphere, which makes up about 21% of the air we breathe. When the flammable gases released during pyrolysis get hot enough, they can react with this oxygen. And this is the moment of magic, the ignition point. This reaction between the hot fuel gases and oxygen is what we call combustion. It's an exothermic reaction, which means it releases energy. And it releases that energy into very noticeable forms, heat and light. The intense light is the visible flame we see, the glowing, dancing part of the fire. The colors of the flame can tell you a lot about what's happening. A blue flame, for instance, indicates that the combustion is very efficient, with plenty of oxygen, and it's very hot. The yellow and orange colors we typically see in a wood fire are actually caused by tiny, glowing solid particles of soot, which are in burnt carbon. These soot particles get superheated and incandesce, just like the filament in an old light bulb. So you have fuel, heat, and oxygen coming together in a rapid chemical reaction that produces even more heat and light. And here is the key to why a fire keeps going. It has a self-sustaining chain reaction. The heat released by the combustion process is more than enough to continue the pyrolysis of the nearby fuel, releasing more flammable gases. These new gases then mix with oxygen and burn, releasing even more heat, which breaks down more fuel, and so on. The fire feeds itself, creating a continuous cycle as long as there is enough fuel and oxygen available. This chain reaction is the fourth element sometimes added to the fire triangle, turning it into a fire tetrahedron. You have fuel, heat, oxygen, and the chain reaction itself. This is why some fire extinguishers, like those with halon or other clean agents, work by interrupting this chemical chain reaction, even without completely removing the heat or oxygen. Now let's talk about what's left behind. After the fire has consumed all the available fuel, what remains is ash. Ash is made up of the non-combustible minerals that were present in the original fuel, like calcium, potassium, and other trace elements. The rest of the material, the carbon, hydrogen, and oxygen, has been converted into gases like carbon dioxide and water vapor, which dissipate into the atmosphere. So to recap, you start with a fuel source, like a piece of wood. You add enough heat to start pyrolysis, which turns the solid fuel into flammable gas. This gas then mixes with oxygen from the air and ignites, creating a combustion reaction. This reaction releases heat and light, which we see as fire. And crucially, the heat it produces is enough to sustain the reaction by creating more flammable gas from the fuel. It's a beautiful, powerful, and continuous cycle. Understanding the fire triangle is not just a cool piece of science trivia, it's the fundamental principle behind all firefighting and fire prevention. To put out a fire, you just need to break the triangle. Firefighters douse fires with water primarily to remove the heat. The water absorbs a massive amount of heat energy as it turns to steam, cooling the fuel below its ignition temperature. Smothering a small grease fire with a lid removes the oxygen supply. And creating a fire break by clearing away trees and brush in a forest removes the fuel source. It all comes back to those three simple elements. So the next time you're gathered around a bonfire or lighting a candle, take a moment to appreciate the incredible chemistry at play. You're witnessing a rapid, self-perpetuating chemical reaction that has shaped human history and continues to be one of nature's most powerful and captivating forces. From a tiny spark to a roaring inferno, it all comes down to fuel, heat, and oxygen working together in a perfect, fiery dance. Thanks for joining me on this scientific deep dive into the heart of the flame. I hope you found it as fascinating as I do. If you enjoyed this video and learned something new, don't forget to hit that like button and subscribe for more content that explores the science behind our world. Let me know in the comments what other everyday phenomena you'd like to understand better. Stay curious, and I'll see you in the next video.